So let's have the solution to example 24. Replace the two forces and a couple acting on the bent rod ABC with an equivalent force couple system with the force acting at C. So remember that couples are free vectors, meaning you can move the couples anywhere to their planes or to their parallel planes, so we can combine couples. So let's compute first the equivalent resultant force at C. So let's resolve 100 Newton force, 120 Newton force into vectors. Let's transform them into vectors. For the 100 Newton force, it is magnitude 100 times the vector representation of unit vector representation of its direction, which is 0i plus 2j, because it is 2, right? Then going down to then minus 2k. So f1 is 100 times 2j minus 2k all over square root of 0 square plus 2 square plus negative 2 square. So in vector form, the 100 Newton force is 70.71j minus 70.71k newtons. Then for the 120 Newton force in vector form, so it is directed backward 1.5, then rightward 2. So it is 120 times negative 1.5i plus 2j divided by square root of negative 1.5 square plus 2 square plus 0 square. There's no z along z. It lies on the same, on the xy plane, so there's no z0. Simplifying, it is equal to negative 72i plus 96j. Therefore, the resultant force acting at C would be expressed in vector form as negative 72i, then 70.71 plus 96, that's 106 something, then minus 70.71k. So R in vector form is negative 72i, 166.71j, so that's 70.71 plus 96, 166.71j, and there's only negative 70.71k. Next, for the 180 Newton meter couple, let's transform it into vector form. So it is magnitude 180, then multiplied by the unit vector of this direction. So if you follow the right thumb rule, the curling of your forefingers should be the same curling as that of 180. And this is the right thumb direction. So the unit vector of this is negative 1.5i plus 2k. There's no j. It is on the xz plane. Divided by square root of 1.5 square, negative 1.5 square plus 2 square, which is 2.5. So couple AB is 180 times lambda of AB. So 180 times negative 1.5i plus 2k over 2.5. Remember, 2.5 is the magnitude of square root of negative 1.5 square plus 0 square plus 2 square. So in vector form, the couple is negative 108i plus 144k. Then let's compute the moment of the 100 Newton force about point C. So we use cross product, and we will explain later. Let's verify later that the moment by the scalar method by right thumb rule would be the same. So for the moment of the 100 Newton force about point C, so it is either RCB cross the force F1, or it's also RCB, because B is the point on the line of action of the 100 Newton force. It's also D, but I'll use D. It's up to you to use B in your free time and verify that the results will be the same, because I will also use for the 120 Newton force later. It is RCB cross the F2, although it is also RCA cross F2. So for the F1, moment of F1 about C, so it is RCD cross F1 or RCD cross F1. But I'll present this one. So CD is going down, so it is 0I, 0J, negative 2K. So it's negative 2, the component. Then F1 in vector form is already computed. 0, 70.71, then negative 70.71 unit vectors IGK. Copy the first two column elements. Then let's expand. So for I, 0 times or negative 70.71 times 0, so 0. Then minus 70.71 times negative 2, so that's positive 2 times 70.71. For J, so it's 2 times 70.71, that's 141.42 I. For the J, it's 0 here, 0, then 70.10, so 0. There's no Y component of moment of F1 about point C. Then for the Z component, so we have 70.71 times 0, so it's 0, then also 0. So there's only X component of moment of the force F1 about C, and that is 141.42 I Newton meter. So let's verify that there's only moment about X for the 100 Newton force. Then I can resolve 100 Newton force into two components, namely going right 70.71 J, which is 70.71, and going down 70.71. So if this is C, this is the x-axis, the y component of the force, component of 100 Newton force passes through Cx, so it's 0. And this one going down is producing positive moment if you follow right thumb rule. So it is 70.71. So this is 70.71 times 2, which is the same as the 70.71 times 2, which is 141.42 I. About Cy, since the 100 Newton force acts on the Cy axis, so that's why it's no moment, or in other words, parallel to Cy, 0. Then the vertical component passes through Cy axis, so it's 0. That's why there's no J component of moment of F1. Then for Z, so obviously the 100 Newton force passes through the Z axis. So if this is the CZ axis, the Y component passes through CZ, then the Z component is parallel to Z, so it has no moment. So that's why it really proves that that's the moment of the force F1 about point C. Now let's proceed to the moment of the 120 Newton force about C. So let's use RCD cross F2 instead of RCA cross F2, although there are two ways to solve for the couple or the moment of F2 about point C. So I'll present this. So RCD again is 0, 0, negative 2. Then components of F2 would be negative 72, positive 96, then 0. There's no Z component or F2. Then unit vectors, then copy the first two column elements. So let's check. For I, it's 0 here. Then minus negative 96 times 2. So minus negative 96 times 2 is positive 96 times 2. So we expect that 96 times 2 is 192I. For J, we have negative 2 times 7, negative 72, or 72 times 2, 144. Then minus 0. For K, 96 times 0, so 0, 72 minus negative 72 times is 0. So for C sub 2, it is only 192I, which is this, then plus 72 times 2, 144J. So 192I plus 144J. So how about the scalar way? So component of 120, let's transfer it at D by principle of transmissibility of a force. So the components are 96 along Y, then negative 72 in that direction. So if this is the x-axis, The negative 72 or 72 Newton backward has no moment about Cx because it is parallel to. Then this 96 Newton component, which is in this direction here, will have a positive moment about Cx by right thumb rule. Position your right thumb towards the Cx axis. The curling of your four fingers will be the same curling as this component of force. So 96 times 2, that's Cx. 96 times 2, which is this, is 192i. Then about y-axis, so this is cy, so this is 96 parallel to y, so it has no moment. This is 72 going to the right, so or backward, and this is cy, right thumb rule, so positive 72 times 2. 72 times 2 is equal to 144j. So that's it. Let's prove that there's no z component of moment. So this is 96, then this is CZ axis, so the 96 Newton component passes through CZ, the extension of CZ axis, so 0. Then this is 72, it also passes through CZ axis, so that's why there's no Z component of moment of F2 about point C. So that's why this is really the component of moment. So finally, the resultant couple would be negative 108 plus 141.42 plus 192i. So that would be equal to 225.42i. For the j, it's 144 only. For the k, it's also 144. So that's the resultant couple at point C. So this is the resultant force when the force is applied at C. This is the resultant couple also at any point, not necessarily at C, because couples are free vectors, or we can add the couples correspondingly.